Are you ready for some trig mad minutes? I would normally give you 5 minutes to do as much as you could on this worksheet and give myself about 2 minutes. So I have 2 minutes up and running on my watch, and I will hit start, and my goal is to try to get through at least 15. I could not get through the entire page in this amount of time. So see, you don't have your calculator or anything like that. Let's see what happens. I'm going to hit start on my timer. 3, 2, 1. Oh my gosh, I'm off to a very slow start already. Let's see. I forgot all math. Oh my goodness gracious me. I'm just gonna cheat and make a little triangle right there. That's gonna make life easier. Maybe 1 over square root of 3. All right, this is square root of 2 over 2. There we go. I'm getting my rhythm now. Let's see, cosine up there is going to be 0. I think that's going to be 1. This is going to be square root of 3 over 2. Cotangent up here, let's see, what's cotangent? That's cosine over sine. This is going to be 0. See, this is really a negative pi over 3, which is a 60 in the fourth quadrant. Sine would normally be square root of 3 over 2, so this is going to be 2 over the square root of 3. It's negative because we're in that quadrant. We got to rationalize 2, rad 3 over 3. Let's see, negative 45 in the third quadrant. It would normally be square root of 2 over 2, so this is going to be square root of 2 negative, oh god, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so that's right here, which is 0, negative 1. Tangent is sine over cosine, so this one's undefined. I think this is the same as 11 pi over 6. That's what I'm going with. So that's going to be square root of 3, and it's negative. I have no idea what this is. Math. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so it's way over there. It's a 60, it would normally be, so it's going to be 2, I think. Negative, because of that quadrant. Down here, this is going to be a negative 11 pi over 6, which is in quadrant 1. Sine, so that's 1/2. Negative 45, it would be a negative square root of 2. Cosine of 13 pi over 3. Okay, so this one was... Oh my goodness, I have no idea. Did I do that one wrong? Did I forget the negative? Oh my goodness. This is terrible. This is the longest 2 minutes ever. Stop. I failed on the last one that I was trying to get done. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Alright, so this one would be 1/2. And my guess is I did this one wrong, actually, because I don't think I went negative. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Well, I got lucky. That is actually negative 2, but it's actually in quadrant 2, not 3. Whew. That was tough. Well, based on that kind of slow and rough performance with radians, I'm not looking too confident with these degrees, especially with these big numbers that I'm going to have to actually do some subtraction on. But again, 2 minutes on the clock. We'll see how far I can do it. I would have given you, I don't know, 5 minutes probably in class just for fun. Do this. Starting in 3, 2, 1. Oh boy. Square root of 3 over 2. This is going to be 1 over the square root of 3, which we got to rationalize. Square root of 3 over 3. Cosine of 0, that's going to be 1. Sine of 0 is 0. This is square root of 2 over 2. This is going to be 1. Oh boy. This one gets hard. Got to do math here. 315. All right, so this is going to be a square root of 2 over 2. It's positive in the fourth quadrant. Negative 240. Oh boy, math. That's going to be right there. It's a 60. Sine would be square root of 3 over 2. This is going to be 2 rad 3 over 3, positive because of the quadrant it's in. Let's subtract 360 twice from this one. I cannot do that math in my head. Can you? That's 180. Oh my gosh, what is cotangent of 180? This would be cosine over sine. Is this undefined? Oh my gosh, I'm not positive about that one. That was rough. There, 1, 2, 210. Okay, so this is really a 30. It's going to be a square root of 3 over 3. It's positive because it's in the third quadrant. Wonderful. Let's add 720 to this. It's going to give us negative 60. Secant of that is going to be a positive 2. Oh gosh, of 90. If that one was 1, then that one's 1. subtract 360 from this, and what do we get? I have no idea. Math is really, really tricky. It's really only 60 more? My goodness. And math. All right, 2, 1, negative 120. Okay, so that's a 60. So this is going to be a square root of 3, and it's in the third quadrant, so it's positive. I think this says 150. I can't really tell. I'm going to do square root of 3 over 2. It's negative because of that quadrant. And I have 7 seconds to spare. I should have written more down. I wasn't confident enough. Stop. That was fun. For questions 1 and 2, we just have to find the rectangular coordinates of the point with the given polar point that we have here. So we can use our equations over there to help us figure this out. I also like to sketch a quick graph of them so that I get an idea. So 3 pi over 4 would be here, but with a negative radius, it's going to end up being down here. So I know that I'm going to end up with a positive x and a negative y. So it's like a little double check to make sure that I'm doing things right. So I'm going to do negative 6 cosine theta and negative 6 sine 3 pi over 4. That's going to be my point. If they're special angles, then we have to reduce it. So cosine of 3 pi over 4 is going to be a negative square root of 2 over 2 times the negative 6. We got negative 6 times a positive square root of 2 over 2. So that's going to be positive 3 square roots of 2 and negative 3 square roots of 2. So this is the xy rectangular point for that given polar point. Do the exact same thing for this one over here. So I'm going to have 7 cosine 2 pi over 3. That's going to be the x. I'm not going to run out of space, so I'm just going to say y is going to be 7 sine 2 pi over 3. So let's think, that's a 60 in the second quadrant, so that's going to be negative 1/2. This is a 60 in that, so that's going to be square root of 3 over 2. There we go. So we have a negative 7 over 2 and a 7 rad 3 over 2. And I forgot to do my quick little graph to see where this was. So 2 pi over 3 is over here, and 7 is positive going in the same direction. So I should have a negative x and a positive y. So this makes sense. Okay, for questions 3 and 4, we're being asked to plot the given point, then find the other coordinates for it. So basically the positive, 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 negative, negative, positive, negative, negative, and then an equation for all possible polar points. So if we start off with number 3, here we're going to first find pi over 4. So that's this one. Remember, we extend it in both directions. And then because it's negative 2, I'm going to go in the opposite place. So I'm going to go down 1, 2, and there's going to be my point right there. I'm just going to plot this one first because it's easier for me to plot them before I do all this other typing stuff. So here I'm going to find 46. So it's just a little bit past this middle line here, right there we'll say. And then I'm going positive 3 in that direction. 1, 2, 3, boom, there we go. So now let's go about trying to figure this stuff out. So I'm going to do a positive radius with a positive angle. So all the way around, that's going to be 5 pi over 4. So 5 pi over 4. Then I'm going to do a positive radius with a negative angle. So that's going to be negative 3 pi over 4, I believe. 3 pi over 4. We already have the negative radius with a positive angle. So now let's do a negative radius with a negative angle. So I need to come all the way around. That's going to be a negative 7 pi over 4. So remember, when we have negative radiuses, we need to be in the opposite quadrant from where the point actually is. Now, in order for me to write the equation for all possible points, I just need to pick one of the positives and one of the negative radius ones. So I'm going to just pick the first two because those are the easiest ones. So I'm going to do 2, comma, 5 pi over 4, and then I do plus or minus 2 pi k. Straightforward. I'll do the same thing with this one. Negative 2, comma, pi over 4, plus or minus 2 pi k. Done. Oh boy, over here we got to do some math to figure these things out. So they gave us the positive, positive. Let's find the other positive radius, but with a negative angle. So I need to do 360 minus 46, and that should be negative 314 degrees. Now I'll do negative radius for both of these ones, negative radius. So that means I need the angle to bring me over here if I have a negative radius, because it will shoot it back across. So using a positive angle, that's going to be 180 plus 46, so that's 226. And then I need a negative angle, that's going to be 180 minus 46, so that's going to be a negative 134, I believe. And then again, to find all of them, I just pick one positive radius one and one negative radius one. So I just always choose the ones with positive angles. So this will be 3, 46 degrees, and then plus or minus 360 degrees times k. And I'm just going to copy that part so I don't have to type it again when I'm over here. So this is negative 3, and I'll do 226. I should have copied the degree symbol. Plus or minus 360k. And there you go. For 5, 6, 7, and 8, we are given rectangular points, so x, y, and we're being asked to find 2 pairs of polar coordinates that work between 0 and 2 pi. So we're basically going to have to use a positive radius and a negative radius. So I always like to graph these things first just to see where they are. So positive 3, negative 3, that's going to be down here. And part of doing this allows me to actually see what this is. So I recognize this already. This is a 45, 45, so I know that the radius is going to be 3 rad 2 following the pattern. So if I do positive, let's see, I'm going 0 to 2 pi, so this is going to be 7 pi over 4. Now if I use a negative radius, then I need to end up over here, so that's going to be a positive 3 pi over 4. And those are going to be the 2 points. Same idea for 6. I'm just going to do a quick sketch of this thing. So it's in the first quadrant. It's going to be 6. This is 2 rad 3. So this one's a little bit trickier to see what's going on, but I think that this is the x side and this is the x rad 3, because if I did 2 rad 3 times another rad 3, I would get 6. So that means that this is the 2x side. So that's going to be 4 rad 3 as my radius. And let's see, if this is the x rad 3, then that's the 60. So I'm going to have 4 rad 3 is my radius, and then 60, but I'm in radians, so pi over 3. And then I need to pick this one over here with a negative radius. And let's see, that's going to be 1, 2, 3, 4. So 4 pi over 3. And those are going to be the 2 points that work for this one. For 7, I'm just going to graph it real quick. It's way over here, so I know that I can, that is not where it is. Oh my goodness gracious me. Math, tricky. 0 down here. Let's see, I already know what its radius is. It's just going to be square root of 3. So I'm going to have square root of 3 comma 270, so 3 pi over 2. And then I need to end up over here, so I can use pi over 2 with a negative square root of 3. So all I'm doing when I'm doing this stuff, in case you're a little unsure, is when I use a negative radius, I'm making sure that I'm 180 away from where I actually want to be. Last but not least, we have this one. Just like up here, when the x and y are equal, I know it's going to be a 45. I just need to figure out what quadrant it's in. They're both negative, so I know it's going to be over here. So if this is 5 rad 2 and this is 5 rad 2, that's following our normal pattern of x, x, and x rad 2. So this side is going to end up being 10. So I'm going to have 10 5 pi over 4, because this is a 45 in the third quadrant. And then I could also end up over here with a negative 10 and a positive pi over 4. And these will be the 2 points that will work. For 9, 10, 11, 12, 13, and 14, we're given polar equations. We need to convert them to rectangular equations, so we'll just be using our formulas up there. So here I really need this to be r sign, so I'm just going to multiply both sides by r. I'll replace the r squared with an x squared plus y squared. Replace the r sign with a y, and now I just need to keep going with it. So I'm going to subtract it to the other side, and I will be completing the square here. So this is going to be 25 and 25. So I have x squared plus y minus 5 squared equals 25. So this is a circle. It has a center at 0, 5, and it has a radius of 5. 10's annoying because it's not going to work out nicely for us no matter what. So I need to basically multiply everything by r. So I'm going to get r squared equals r plus 2r sine theta. So that's going to allow me to replace these guys, but I'm still going to have this extra r here, which we can do with like, you know, plus or minus and et cetera, which is basically our only solution here. So I'm going to have a plus or minus an x squared plus y squared plus a 2y. And that's just about the best that we're going to be able to do, I think. So there is nothing else that we could do with this. We don't know what equation this is, right? I mean, I don't know. We could plug it into graphing software and see what it is. But my guess is it's not going to be anything that we're familiar with. In fact, I know it's not going to be anything that we're familiar with. It's going to look something like, I don't know. My guess is it's going to look something like that if we were to actually graph it. Like this weird inner circle thing going on there. 11, just multiply everything by r, replace the r squared with x squared plus y squared, replace the r cosine with an x, and then we just have to complete the square. So I'm going to have a minus x plus something plus the y squared equals plus something. Fractions. So this is going to be 1 over 2 squared. That's 1/4. That's 1/4 over here. So I'm going to have x minus 1/2 squared plus y squared equals 1/4. So it's going to be a circle with a center of 1/2, 0. It's going to have a radius equal to 1/2. Wasn't that terrible, I guess. If you didn't get the first step is probably going to be multiply everything by r. That's what we're doing. So when I do this, I'm going to have r squared equals 2r sine theta minus 2r cosine theta. So that's going to become x squared plus y squared equals 2y minus 2x. And then I'll just complete the square. So I'm going to have plus 2x plus a blank plus y minus 2y plus a blank equals plus blank plus blank. So when we do this, it's going to be a 1 and a 1. So I will have x plus 1 squared plus y minus 1 squared equals 2. So this is a circle with a center at -1, 1, and a radius equal to the square root of 2. There are like 8 million of these questions. 13, I'm just going to distribute the r through everything. So I get r cosine theta minus r sine theta equals 4. R cosine is x, r sine is y, so I get x minus y equals 4. So this is a line, and that's really all I need to do about it. I don't need to do anything else. 14, I'm just going to multiply everything to the other side and distribute that r through. So I'll get 4r sine theta plus 5r cosine theta, and that equals 2. So r sine is going to be y, r cosine is x, so I get this. This is also a line, so I'm just going to leave it that way. For 15, 16, 17, 18, 19, and 20, we are given rectangular equations and we need to convert them to polar. And I started off with just about the 2 worst ones we could use. They are kind of tricky. So when I have y equals x, there's a couple different ways that we could look at this. So first I could just substitute everything in. So let's try it that way. I would get r sine theta equals r cosine theta. If I divide everything by r, then there are no more r's. So I get that sine theta equals cosine theta. I can then divide, so I have tangent theta equals 1. Sine over cosine is tangent equals 1. So we could technically leave it this way. This technically works. But what we would actually do is go the next step further, which is solve for what this theta value would be. So if tangent equals +1, then theta either equals 45 degrees, or we could say that theta equals, 225. And this should kind of make sense. If I were to graph x equals y, it's a line that goes like that, right? So if I have a polar equation that just says theta equals 45 with no r value, it means that r equals all values. So as long as I'm locked on this angle of 45, then every single r value, positive and negative, works. So any one of these ones officially works. These two right here are the ones that are definitely preferred. 16 isn't super hard, it's just kind of annoying, if I'm being honest with you. I'm going to plug in x squared and y squared, so I'm just going to square everything. So I'm going to get r squared cosine squared theta minus r squared sine squared theta equals 4. And I'm going to factor out an r squared. So I'll get cosine squared theta minus sine squared theta, and that equals 4. And let's see here, this is an identity. I know you've forgotten about them, but they still exist. And that's actually cosine 2 theta. So we can do r squared cosine 2 theta equals 4. And we would probably leave it this way. There's really no reason for us to move it over. I suppose if you really wanted to, we could rewrite it as this. But we're not really going to be able to reduce it any further than that. So we're just going to leave it that way. Either one of these ones. 17, 18 are a little bit easier. So I'm just going to apply the formulas here. So I have 2r cosine theta plus 3r sine theta equals 6. And let's see here. What do we want to do? I think we can just factor out an r maybe? Yeah. So we'll get 2 cosine theta plus 3 sine theta equals 6. And typically we would just write this on the other side, like so. And we're done. That's all we would do. 18 is even easier. We have x squared plus y squared. We have a direct substitution. So we have r squared equals 169. We could take the square root of both sides. We'll get r equals 13, or we could say r equals negative 13. It really doesn't matter. And that's going to be our answer. Let's think about this the same way we did with 15. If we were to graph this thing, this is a circle centered at 0, 0 with a radius of 13. If we don't include a theta value, it means all thetas. So this is all angles that have a radius of 13, and that will create this circle. If we did a negative, that would work just as well. It's just that at an angle of 0, we would be starting over here on the circle, and we'd fill the bottom part of the circle first, then the top. So it doesn't really matter which one you pick. We just would normally use the positive 13. 19 and 20, hardest ones in the entire document. Not really, that was a joke. X r cosine theta. So I got r cosine theta equals 3. I'm just going to divide the cosine to the other side, and that will give me a secant. So I have r equals 3 secant. Done. Same exact idea. I'm going to have r sine theta equals 6. I'll divide the sine theta to the other side, so I will get a cosecant theta. So r equals 6 cosecant theta. And there you have it. All done. Oh god, making a mess everywhere. Yeah.